Howdy! In this mini lecture we will discuss ocean acidification, ocean trophic levels, consequences of industrialized fishing, and fishery management. The student learning objectives of this mini lecture are: explain the cause and consequences of ocean acidification, describe the biodiversity of the ocean, identify the different trophic levels of the ocean food chain, assess consequences of industrialized fishing, review the state of ocean fisheries and reasons for the decline, and evaluate marine protected areas and reserves as innovative solutions. There is an excellent video on ocean acidification posted in eCampus you need to watch. In short, ocean acidification is caused by oceans absorbing excess CO2. Please watch the video posted in eCampus for more information on this critical environmental problem. The open ocean is a rich and diverse ecosystem, and the distribution of the biodiversity varies throughout the pelagic zone. The most productive areas of the ocean are regions where upwelling has brought up nutrient-rich waters. In this way, upwelling supports high surface primary productivity and an abundance of different animals. The base of the ocean food chain is the photosynthetic, microscopic phytoplankton. Phytoplankton include algae, protists, and cyanobacteria. Phytoplankton are therefore primary producers of the ocean. The primary consumers in the ocean food chain are zooplankton. The zooplankton are the food source for the secondary consumers, which are fish, jellyfish, and whales. Finally, the top of the ocean food chain are the predatory tertiary consumers, such as tuna fish, sea turtles, and sharks. One of the greatest threats to the oceans today is overfishing. Fishing, like farming, has gone from sustainable, traditional, and subsistence-based to an industrialized process. Whereas once fishermen caught enough for themselves and to sell a few to support their families, now industrialized fishing fleets are engaging in intensive fishing methods. Specifically, fishing fleets are fishing in increasingly remote areas, capturing smaller fish than before, capturing less desirable species, and using huge vessels that use powerful technologies to capture fish in huge volumes. The common methods of industrialized fishing include drift nets, long lines, and bottom trawling. Drift nets are long transparent nylon nets that are set out to drift in open water to capture schools of fish. Long lining is the use of fishing lines that have baited hooks spread out at equal intervals along the line. There can be anywhere from 25 baited hooks on a line to 2,500 baited hooks. The number of baited hooks is usually determined by the stability of the fishery. Bottom trawling drags weighted nets across the floor of the continental shelf. Sonar can be combined with any of these methods to increase the yield of the catch. All three of these industrialized methods are indiscriminate methods of fishing and inevitably result in bycatch, which is the accidental capture of non-target animals. Bycatch causes the death of millions of animals each year, and each method is incredibly destructive. Drift netting drowns dolphins, seals, sea turtles, and non-target fish. Longline fishing kills turtles, sharks, and seabirds. Bottom trawling is likened to clear cutting and strip mining because it destroys complex communities such as coral reefs. You can see from this infographic, industrialized fishing alters the ecosystem structure and function because it artificially reduces the number of species at each trophic level. It destroys or modifies marine habitats and causes incidental mortality through bycatch. What this all means is that we are threatening the balance and functioning of marine and coastal ecosystems. As should be abundantly obvious, people are over-harvesting marine species. This infographic shows how fishing has escalated since 1950. In 1950, we didn't fish in the high seas. In 1980, we were fishing in 33% of the high seas, and then by 2006, we were fishing in 63% of the high seas. This increase in fishing in high seas equates to extracting more fish out of the ocean than ever before. In 1950, only 1% of all marine fish were exploited, overexploited, or collapsed. As of 1980, 39% of marine fish populations were exploited, overexploited, or had collapsed due to overfishing. Fast forward to 2006 and this number jumped to 87%. Industrialized fishing is single-handedly depleting worldwide fishery stocks. If trends continue as they are today, populations of ocean species used for food will collapse by 2048. A collapse would mean loss of ecosystem services and reduced ocean productivity, not to mention a main protein source for about 20% of the world's population. Fisheries can be managed just like other semi-renewable resources. Traditionally, management has been based on maximum sustained yield. Recall this strategy keeps the resource at half of its carrying capacity because the resource grows the fastest at this size. The goal of maximum sustained yield is to calculate the number of fish that can be harvested without reducing future catches. However, despite management, stocks have plummeted. Many experts advocate that it is time to rethink fisheries management and move towards using ecosystem-based management and shift the focus away from species and towards the larger ecosystem. Experts are also calling laws that protect ocean areas and help species recover. To this end, scientists suggest protecting 20 to 50% of the ocean as no-take areas, meaning fishing could not occur in these protected areas. There are two general ways oceans and fisheries are protected: marine protected areas and marine reserves. Currently, there are about 1,600 of marine protected areas, MPAs, along the coastlines of developed countries. MPAs are areas of ocean designed to protect marine life from fishing pressures. However, fishing is still allowed to some extent. MPAs also are designed to protect local cultures, economies, ecosystems, and provide for sustainable production of marine resources. However, MPAs have been criticized because some feel restrictions are not stringent enough to protect marine species and habitat. Marine reserves, on the other hand, are protected areas where fishing is prohibited. Marine reserves are in places to restore the ecosystem and eliminate human interference. Marine reserves have been shown to improve fisheries surrounding the marine reserve because the population of young fish increases in the marine reserve and they then disperse into areas outside of the reserve. Reserves have been shown to improve the ecosystem and allow the natural system to restore itself, compared to nearby fished areas. For economic and other anthropocentric reasons, though, many commercial and recreational fishers do not support reserves. After all of this, you may be asking yourself, what can I do? Consumer choice can encourage sustainable fishing to help the cause by only purchasing seafood sourced from sustainable fisheries. The Marine Stewardship Council and the Monterey Bay Aquarium have developed guidelines for people wanting to choose the most sustainable seafood. They even have apps you can download to your phone so you can always make the most sustainable choice when selecting your seafood. That concludes this mini lecture on ocean acidification, ocean trophic levels, consequences of industrialized fishing, and fishery management. Please review the weekly outline and complete the activities for this week per the schedule set forth in the outline. Thanks and gig 'em!